Okay, I'm gonna try to do a thorough overview in this video. There's a few things we want to look at. In here, we have my report that I typed up, and so I just want to kind of go over the whole system to make sure we're all on the same page, and I'm going to give my recommendations on how to best fix stuff. I put things in writing here as far as what the actual findings are, and then we will just kind of look over the system and what it is. Now, this drawing of this system is not complete. So what I mean is there are details missing in this drawing. The reclaim drag conveyors are missing. The receiving drag is missing. This drawing is basically for the grain flow overhead to explain what's going on and what I would recommend for fixing. So we're going to start on the first thing that I have in my report, which is that the spout to the main south wet bin, the angle of that spout. Now we want to look here at the way that is designed. That has two different ways to get to it. We're going to look at the wet grain flow. So the wet grain flow, the grain comes out of the distributor, goes into the cushion overflow valve, drops down, goes to a K valve, which then kicks out and dumps into that spout. And then at that point, the spout goes down to the bin. So for fixing that spout has too steep of an angle. So I'm going to recommend to fix that spout, you would just go right here. I'm going to try to show this as best as possible. But right here where those three spouts come together, what I would do is put a drop pipe here about 5 foot and put a dead stop. And when I say a dead stop, I mean one of these right here. One of these where the pipe comes down and then kicks out. So that's what I would do over here, is put like a 5 foot drop pipe where these spouts all come together. Put like a 5 foot drop pipe and a dead stop. That will shorten this spout and reduce the angle of this spout so that the grain speed is not exceeding recommended speed. This spout should not be more than, it should be between 45 and 50 degrees. So I think a 5 foot drop on there should get us real close to that. While I'm on this, before I move to the next, I want to say bin heights are not exactly like system. I did not take side pictures of the facility to get my bin heights right, so just while reviewing this video, this is to explain grain flow overhead. That's all this drawing is for, is to explain grain flow because of all the different short angled spouts up in here. It's just going to be easiest for me if I can explain it with a drawing. So I would do a drop pipe off of there about 5 foot, 4 or 5 foot, something like that. Put a dead stop in, and then kick that spout out to the wet bin. Now on the top of that wet bin is a impact plate, I'm going to call it. This is what's on top there. And when grain is moving excessive speed and just hitting a flat plate, it will, right there, that spout that's the pipes I'm talking about, where it has the K valve there, the drop pipe off the distributor, and this other pipe coming off the distributor. So, and that's the cushion box, angle box, I'm going to call it. It's not actually a cushion box, as there is no, it's just the grain's just coming and hitting a flat plate. Just to be clear on that, I will show that. This is the inside. Grain comes down that spout, impacts against this plate. This is just a flat plate going down into the bin. That's the spout coming down. And then also, as I'm going through, here is the grain speed. So material will pick up speed as it flows through spout. Consequently, the spout will be less full but still handle the same amount of product. This means there's less surface area for wear. The drawings below show the effect of this increase in speed. The material handling system should be designed such that the spouting is near full capacity. This will help minimize uneven wear of the spout. It will also help reduce grain speed. Spout running at low capacity will tend to run higher grain speeds than spouts at full capacity. So yes, this is putting in full spout. Once it's up to 1600 feet per minute, it's down to that much. Although when running less than full capacity in a spout, you have, if anything, higher grain speeds. Definitely not lower grain speeds. So if we're doing exactly the same, it does not matter on this report because of my findings. This elevator, we'll get to that later. And that. Okay. Now, my second finding was the spout going to dual tube chain conveyor. This is a pretty easy one to see an issue with. This has a spout coming off of the distributor and going straight down for 30 foot and then hitting on what I would call an inline retarder or an inline cushion box. I did not open this box to review the interior of it, but the grain comes down, hits something, pocket of grain, whatever, boils around, goes on down. Then said spout goes 10 foot, hits a set of elbows, and kicks out the side. Now the angle and slope of this spout going to this grain cannon or this dual tube chain conveyor, this spout is within the guidelines of the engineering. This 30-foot spout, straight vertical, is an issue, as a vertical spout should not exceed 90 degrees, which is vertical. We're at 30 feet. That is 2635 feet per minute of grain speed. So to be in here, to be in the gray, we would need to be no more than 20 foot of vertical spout. So that spout, if this cushion, this inline retarder, was in the center and there was a proper dead stop right here, that would give us like a proper dead stop like this. That spout would be within ratings. But since this inline retarder was installed 10 foot lower, we have 30 foot of straight drop here. So in reality, I mean, there's a couple ways to fix this. I would say go in the middle of this 30 foot drop, put another inline retarder in the center of this 30 foot drop, and just to make sure we are seeing it properly, I will change the colors to yellow of the spout we are working with right now. So in this 30 foot spout here, this long straight drop, I would say just because labor is costly, I would say go to the center of this vertical, make sure this pipe is fastened, go to the center of this vertical, cut out a section, and weld in an inline retarder. Then I would highly recommend going down here, removing these elbows, installing a dead stop like this in this location, and then having the spout go out from there. Because with that 10 foot of vertical drop right here, then we're hitting a set of elbows. Whoa, I made a little mistake, hang on. Then, okay. I accidentally X'd out of this last time. So here we have 10 foot of drop. So we're at 1,520 feet per minute when the grain hits those elbows. You can get away with that, but those elbows are not going to last. That's a bad wear point right there, to have 1,500 feet per minute grain hitting that and kicking out the side. There should be a dead stop to cushion that grain and then put it out the side. I'm through this video, I'm going to give you the facts, but I'm also going to give you my recommendations. My recommendation right here, this is like, technically the elbows are all right. I personally would be very upset at my millwright crew if they put elbows at the bottom of a 10-foot drop. It's bad practice. So that would take care of that spout, is the inline retarder halfway up here, and then I recommend a dead stop, but don't have to. Then we go to number 3, spout to loadout bin. So if we look here, we have this spout coming out here to the loadout bin, and if we look here, we're gonna see, and I'm not sure if we can see it in these pictures. Right there, you're gonna see that spout comes off that distributor, comes down here to 45. It's approximately 10 foot long, 8 to 10 foot long right in there. And then we drop straight down 25 foot. And you can even see it in this picture. These leg sections are 10 foot. So that's as high as that leg section, 10, 20, and then this would be 30, but we're about 25 foot there. This does have a proper dead stop on here, so the grain comes down, boils, grain hits grain, cushions it, and then out the side. That is proper. 25 foot of vertical is an issue. 25 foot of vertical after an 8 foot 45 degree drop is a serious issue. That's actually a little more than a 45 degree, the way it looks from here. So having that 25 foot of vertical after that angled pipe, we're getting grain exceeding, whoops, wrong thing. So we're getting grain, we have 25 foot of drop, so we're getting grain exceeding that 2,400, because we already have the grain, when it's hitting that elbow, is already hitting at like 800-900 feet per minute. So our grain is already starting to get some speed, goes around a turn, which slows it down a little bit, and then drops 25 foot straight. So in this pipe, what I would recommend doing is, with this 25 foot of drop here, I would say go 15 foot above this dead stop, go 15 foot up, and put one of those inline retarders 15 foot above this dead stop. Then you have 10 foot of your angled pipe, 10 foot down, it hits that dead stop, drops 15 foot, kicks out the side. That would be my recommendation. But this 25 foot of vertical drop is a grain breaking issue. That's if we want to just look at it here, 25 foot of vertical drop. Let's look at this one. 25 foot of vertical drop, 2,400 feet per minute. So that's an issue. Cannot exceed 2,200 feet per minute. So that's number 3. Number 4 is going to be the spout to the north wet bin. Now this one here is not as big of a deal because the majority of the grain goes through the large wet bin. So that spout is a big deal. This wet bin is a small part of the grain, so it's not a big deal, but while you're doing the work, you can do this one too, although that is something that I wouldn't look at as terrible if it's not changed. The problem with that spout is if we look in here, we have the grain come off this overflow valve, and then it comes down and goes through a K valve, which it has like a pretty high drop, and then drops into that K valve, which I don't recommend. That's going to wear that K valve out. And then we have it drop another like 20 foot below that K valve. So we have close to, when that valve is straight, that grain is flowing almost, I think it's almost 30 foot 20, yeah, it's almost a 30 foot vertical drop. Yeah, so it's almost a 30 foot vertical drop when that valve is in the straight position, and then it hits this dead stop, and then it kicks out to that hopper bin. So there really should be, there's a couple ways to go about fixing that. From new, I would have said drop that valve down 5 foot, put an inline retarder right above it to protect the valve, and that would have gave us a better pipe slope on this wet spout. Since it's already installed, I would not tear all of that apart. I'm not sure how you want to do it. There should almost be a retarder above that valve to protect that valve, but you may be better off doing something below. With that being the wet spout, if we can get our capacity on the receiving up to 9,000 bushel an hour, I would say let that vertical pipe go. If we can't get our receiving above 5,000 or 6,000 bushel an hour, then we need to do some kind of retarder in that vertical drop pipe for that north wet bin. So yeah, that's, and all of these spouts, you take this spout to the wet bin, this spout to this conveyor here, and this spout to here. This is, the design of cushion box on there is not, I would see that as not adequate. From my experience, grain hitting a flat plate is not a good way to cushion grain. That's a great way to have a lot of foreign matter, or in other words, broken grain. So I'm going to really lean towards putting actual cushion box on your loadout, on this spout here, and on the wet bin spout. There really needs to be adequate cushion box. Now on the wet bin spout, if we were running over 10,000 bushel an hour through this elevator, then I would say the box that's on there is fine. But with running the capacity we're running through the receiving, I'm going to really recommend proper cushion box on here, proper cushion box on here, and a proper cushion box on here. And when I'm saying proper cushion box, I'm not saying one of these. This is designed for going vertical, dropping in. Putting that on a spout like this is not a cushion box and breaks grain. So this is not a cushion box. This is a dead stop for a vertical and then kicking out the side. This is in the position it should be, but don't go and install some of these on these spouts because that is not the fix. Yeah, now I'm going to get into some other things. Those are the things that are engineering wise wrong. according to the engineering papers. Now I'm going to get into other things that are visual issues and where I'm going to recommend changes. So let's go to the pictures here. Whoops. So these are our spouts. These are our other pictures. So on the elevator, no, right here. This is on top of the tower dryer. And if you see here, there is 3 inches of straight drop. So this conveyor is bringing this grain in. There's 3 inches of straight drop and then this taper. The grain comes in here and misses this whole taper because it comes out over and goes down. Because of that, this has a deep depth of grain, like this deep. Because of the way it goes out over, this sprocket in here, it runs the grain right through that sprocket. This dropout should start at least 6 inches earlier and go down here. That way the grain coming out here drops down and doesn't run through the sprocket. But due to the short outlet of this conveyor, all of the grain runs through the sprocket. Like it's just running grain through that sprocket all the time. This is not a huge foreign matter issue, but when working on a grain facility like this, where you're getting 5% foreign matter running through the grain facility, this facility does not have one specific thing that is making 5% foreign matter. It has a list of issues, and each problem is making 0.5% here, 0.5% there. And I understand that the grain, we will get broken grain going through the facility. We will get broken grain. It's part of handling grain. But 5, as high as 7% foreign matter increase going through the facility is unacceptable. So I'm not saying this has to be done. I'm just saying this is not designed the way I would like it to see designed. I would like this dropout to be 6 inches earlier to get that grain out. You're going to have still some grain through the sprocket no matter what, just the nature of the beast. This is something that I think should be redesigned in the future. I think dealers should present this to Sukup as needing to be changed. I personally will present it to them as an issue. Then we will look at, I'm going to see what else we have in here. There was some other random things. That was the cushion box. Oh, right here. This here is in the tail of the dual tube chain conveyor. This is in the tail of the dual tube chain conveyor. This conveyor right here on top of these bins. That tail, they are designed to have this cover over the chain so the grain does not run through the sprocket. It's so the grain don't run through the sprocket and so it don't pack grain in the back. This cover is over that chain for a reason, and there are holes cut in this cover to allow grain to flow into the chain. And this was done due to not sure if I can see this anywhere. Not sure if I got any pictures that show this, but it was done. No, I don't. Due to the way this transition was built from new, not from the manufacturer, but from installers, not having a spacer between the cushion box and here, having it dumping flat on top of here. They couldn't get capacity, so they cut this out. So I'm going to recommend putting covers over this. Again, this is one of those things that does minority grain breakage. It's a small amount of grain breakage that happens here. It's you could fix this and nothing else and hardly get a measurable change in the grain breakage on the facility. So it's not like this is making 2% broken grain, but it also contributes to the broken grain. And because of how easy it is to weld a plate steel across these holes, I would recommend that. So then here, this here is seam in the conveyor. The travel of chain is this direction. So this is not like it should be. Now, I'm not going to get real worked up about this. Can this be an issue? Yes, it can be. I would recommend that you get some punches and an impact and go up this is going to the big south bin, and go up, find the seams that are this way, loosen the bolts and pry that conveyor, try to adjust it. It may not be possible. You may need some other stuff along. You might need some steel and jack and stuff to be able to push that straight. And so with the paddles coming up and hitting against here, every time a paddle hits against there, any kernels in between it will break. This isn't a huge issue. This is a little bit like the outlet on the conveyor going into the tower dryer, where it's not a major issue, but it could be a very minor issue. And in this facility, we're working at a lot of minor issues to fix a costly problem. So this is something that's kind of one of them toss-up things where wouldn't hurt to put some steel across, jack up on this, loosen them bolts, get that to slide down. It would be better that way. So that's what I'm going to say about that. And that should just about cover the broken grain issue. Now, spout sizes, 14-inch spout going to the wet bin, rated at 10,000 bushel an hour. We're running I'm going to say for around 5,000 bushel an hour through those spouts due to the capacity of receiving. Now, with the capacity of receiving, there's a picture in here I want to show. This is a 36-inch head pulley. 36-inch head pulley, 140 foot tall, 10,000 bushel an hour. Now let's look at the chart. 36-inch head pulley, 10,000 bushel an hour, 13x7 low pro, 6-inch spacing, 64 RPMs on the pulley shaft, 603 feet per minute. With those buckets so close together, the 6 inches apart, each front edge of the bucket 6 inches apart, running at 603 feet per minute, we need to have a decent space between dumping in to get the grain into those buckets to get them full and up. So there's a few things I don't like about this, and so with this 36-inch pulley here, we have very little room from the center point to the top of the boot. It's not enough room. So this height is, we're looking at 14 inches from the center of this pulley to the top here. It's not enough to get that grain into the buckets. And so this backs up and plugs the conveyor before we hit anywhere close to 9,000 bushel an hour. To fix this issue is a little more complicated. It is because in reality we should have 2 foot. We need 2 foot. That's 4 buckets filling at a time. From here up, we should have 2 foot of opening. Now to do that, we got to be up in here to get our 2 foot. Well, this is above this splice plate between the two leg the boot and the spouting. So this boot is not tall enough. This boot should be at least a foot taller. That way we could actually get some inlet into there to get the grain dumped into the buckets. In 14 inches, we're not going to get those buckets full. And it's proven. This runs full, and we can't get anywhere near 9,000 bushel an hour when the sticker is rated at 10,000 bushel an hour. So to fix this issue, there's 2 things that can be done here, and I am just speaking from experience here because there's no right way to do it, because there's not enough room from the sender to the top of the boot to get that grain in. So there's no right way to accomplish this. So speaking from experience, if I was sending a millwright out to fix this, I would say I want about to cut into this trunk section above the boot, weld a triangle in here so we let that the integrity of the boot there, cut above the angle, cut an opening in about a foot, build a whole transition off of here down to there, and open the front of this up, angle this in, build a whole transition in here. So we are feeding in down here and feeding in up here. We also can go from back here down lower on the boot, although that may or may not feed properly. When you're feeding, this is the upside of the elevator, and when you're feeding on the upside of the elevator, we have it don't feed in properly. So we could possibly increase, because of the vertical vertical pressure of the grain, we could actually increase capacity by bringing this down. 1 or 2 inches, not going to make a measurable difference. This needs to come down. I mean, I would bring it down close to that angle if you're going to do it. Worst case scenario, some grain sets here in the bottom. Bringing this up here would sooner be my fix, although the discharge of this conveyor is kind of low. If this discharge was another 4 foot higher, we could bring that grain into here and have no problem. We could dump it right into here above the boot and get our capacity. So I'm gonna kind of leave that up to whoever is running the welder and the plasma cutter on how they're gonna build this transition. If it was mine personally on my farm, I would probably start by building this down here, run a load of corn through it, see what for capacity you get, and possibly build this up here. But going up here, like in reality, we need an angle from here at, I mean, if we're above a 28-degree slope from here in, there's really no point, because we can't have grain getting taken back down here. So cutting above this here, this into this blue part of the transition, is really not beneficial, because this does throw the grain out, but it can't be. Well, actually, yeah, you could go up here about 6 inches up this blue part, and you would get gain from about 6 inches up, slope it down, and have an opening in here. You would gain capacity there. And in this situation, there's no right way to do it. So if we can gain a couple thousand bushel here and a couple thousand bushel here, then we can maybe get enough capacity, which will increase capacity in the wet pipe, which will also reduce fines from unloading trucks. So I believe that is my complete review of this system. I believe that's going to be my complete review. I did my write-up first. Then with making this video, I remembered a couple minor things. So I may change my write-up a little bit, my report. But yeah, if there's any questions, feel free to reach out and we will go from there. So in reality, there's some of these things I'm laying out where if you change, there's some of this stuff, like if you just switch that cushion box, or if you to a right cushion box, or if you just did this, like there's some of these things that are just this here. It's very small things. It's a lot of small things. Transitioning this down quicker, it's small stuff. It's a lot of small stuff. It's not that there's one huge issue. So I think I covered everything there. So yeah, if there's any other questions, feel free to reach out and I will get you the write-up also.